Alright, so today's video we are going to cover probability. This is going to be the beginning of our last unit over probability. I do want you to take a moment and look at the warning that comes with this unit. Okay, the answer may seem quick and easy, but you really need to stop and think about your answer before you just say, oh, I've got it, this is it. Okay, probability is going to take a little bit more effort, and it's not in the usual math way where we have a really long problem. You're just going to have to sit down and actually think it through. So what is probability? Well, probability, when we study it, we're looking at lottery, casinos, so if we're looking at data, like for a sample size of people, we want to know how many of those people attended college or etc. How many of those are male or female? How many of those had family that attended college before them? Okay, life and death insurance. If you look at life insurance, they want to know what is your probability, your likelihood that you could die at a young age or die unexpectedly. So they're looking for things like, are you a stunt double? Do you smoke? Do you drink? Do you have health conditions? They look at all of those things because the higher the risk, the more your premium is going to cost. Okay, and we use it a lot when we talk about science. So this is where kind of science and math are going to overlap. So throughout this unit, I'm going to be using some different vocabulary words that you are going to need to be familiar with. If you look at this, sample space. A sample space is all the possible outcomes. So if you were to take a look at a sample space of, say, rolling a dice, your possible outcomes are 1, 2, 3, 4, 5, 6. And the reason for that is because there are 6 sides labeled 1 through 6. If you were looking at flipping a coin, your sample space would be heads or tails. If you were looking at, let's see, genders, like if you were saying what are the genders of students on the honor roll, then your outcome, your sample space would be male or female. Let's see. If you were looking for the favorite flavors of ice cream, you could have a sample space of chocolate, vanilla, rocky road, strawberry, pistachio, chocolate chip mint. All the possible ice cream flavors would be your sample space. Okay? Now, an event is one of those things in your possible sample space. So if you go back to the sample space of the ice cream, an event would be that maybe I like chocolate ice cream the best. Okay, now a subset is a smaller set of the sample space. So if we take a look at the dice, a 2 is an event in rolling a dice. Now a subset, let's say we want all the even numbers. That would be 2, 4, and 6. That is what we call a subset of the original sample space. So it's a smaller version. We said I want to know just the evens or just the odds or just rolling a 2. Those are all subsets of the full sample space. So if you had the ice cream example, a subset could be chocolate, vanilla, and strawberry. Okay, so that could be a subset because we know we still have things like pistachio, cookies and cream, cookie dough ice cream, all that kind of stuff. So this is just a subset of the total sample space. All right, so what I'd like for you to do is you see this table here. I want you to get out a coin, and I want you to flip it 10 times. And for each flip, you're going to record H for heads or T for tails. Your numbers are going to be different than mine. So I just want you to go ahead and flip it and see what happens. All right, so I'm going to write what I did when I flipped this a little earlier. All right, so this is what I got earlier. Heads, tails, heads, 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 tails, heads, tails, heads, heads. That's what I got when I flipped it 10 times. So what percent of the time did I get heads? So if I count, I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 out of 10, or 0.7 is my probability. If I were to change that to a percent, that would be 70%. So what percent of the time did I get tails? 1, 2, 3. I got 3 out of 10, which my probability would be 0.3, or as a percentage would be 30%. So the question is what do you think if you flipped the coin 10,000 times? We would get very, very close to 50-50, meaning that I should get tails exactly half the time and get heads exactly half the other time. So I should be seeing 50 and 50%. I just don't have enough flips, enough where I actually said, hey, I'm going to do this as many times as possible. The more I do, I need a larger sample space is basically what it boils down to. Like if you were to poll 3 people what their favorite ice cream was and they all said chocolate, you'd be like 100% of the people like chocolate ice cream. Well, you didn't poll enough people. In this case, we didn't flip enough times. So chance behavior is very unpredictable. We need to, in order to create a regular pattern, we need to do it over and over and over and create a larger pool. Like we need to poll more people, we need to flip the coin more times. So this kind of is the same thing whenever you're working in the stock market. If you try to put all your money into one, so if you're trying to put all your money into one stock, let's say, Apple or whatever, okay, if they don't do well, then you don't do well either. If they do very well, you do well. So it's very unpredictable, okay? Now, also in the stock market has its ups and its downs, right? But over the course of a long time, our stock market is increasing. So if you try to put your money into a stock market from here to here, you're going to lose money. But if you put your money from here to here, or even here to here, notice that you have then gained money over the course of time. Okay, so you're playing games of chance whenever you're playing with stocks and bonds. All right, so the idea of probability is that events like spinning a spinner, flipping a coin, and it landing on heads, they're erratic with just a few. So we need to create an event that will actually happen multiple times, thousands of times, not even hundreds, thousands. You would have to sit there and flip that coin over 1,000 times in order to get it close to 50-50. Now, math is the ideal world. This is when I figure out the math, this is what I should get. You guys know in science that you do the math and you're like, this is what I should get. But we don't always get that when we experiment, okay? So math, what we're working on is in the perfect world, this is what should happen. Doesn't necessarily mean it's going to happen in the real world. That's why it is called an idealization, okay? All right, now what I want you to do is I want you to flip 3 different coins. So you're not going to have anybody around you, but I would take 3 different coins and now flip them. So the first coin is going to have either a heads or tails for its sample space. The second coin is going to have a heads or tails for its sample space. And the third coin is going to have heads or tails for its sample space. So what are the total possible outcomes? Take a look at this. Okay, this is a probability tree diagram. So this is my first coin, and I can either get heads or tails. This is my second coin here, and depending on what I got the first time, I could still get heads or tails, heads or tails. And my third coin is this row. So let's say that you all flipped heads. That would be this pathway, heads, heads, and heads. Let's say the first coin was a tails, then a heads was the second coin, and tails. So this would be your outcome if that was the case. So there are a total number of 1, 2, 3, 4, 5, 6, 7, 8 total possible outcomes. You could have heads, 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 tails, heads, tails, heads, heads, tails, tails, and those are the first 4. Then you could have tails, heads, head, tails, head, tail, tails, tails, head, and tails, tails, tail. That would be the 8 total. All right, and we call it a tree diagram because it shows all the possible outcomes and it kind of looks like a tree. So let's create a tree diagram for flipping a coin and rolling a 6-sided dice. Now when we flip a coin, we have 2 options, heads or tails. After I flip the coin, I have 6 possible options on my dice. A 1, a 2, a 3, a 4, a a 5, and a 6. And we have the same exact option for tails. So this right here is a tree diagram for both flipping a coin and then rolling a 6-sided die. So let's take a look at this, okay? This is the same thing I created. We have heads or tails with the 6 dice. So this is I flipped a heads and rolled a 1. This is I flipped a head and rolled a 4, flipped a tails, and then rolled a 3 on my dice. So what's the probability of a coin landing on tails and rolling an odd number? So I'm looking at tails and odd numbers. So there are 3 possible choices out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 out of 12 or 0.25. Okay? You must remember that probability is always between 0 and 1, so we're looking at the decimal here, not 25%. All right, what's the probability of rolling a 4? I have a 4 here and here. It doesn't say anything about heads or tails, so that's 2 out of 12 or 0.167. And last but not least, what's the probability of a coin landing on heads and rolling a 6? That only happens once out of all of the 12, so 0.083 repeating. All right, so this right here, this box, is a sample space for rolling 2 dice. I can roll a 1 and then a 1 and then a 2, 6 and then a 6. So how many possible outcomes are there? If you were to count, this is 6 by 6, or 36. What is the probability that the sum of 2 dice adds to 3? 2 plus 1 and 1 plus 2 is 3. So that would be 2 out of 36 as a decimal is 0.056. What's the probability that it will add to 7? 6 plus 1, 5 plus 2, 4 plus 3, 3 plus 4, 2 plus 5, and 1 plus 6 all add to 7. So that's 6 out of 36 or 0.1667. All right, so how do we calculate larger sample spaces? When I roll 1 die, the sample space is 6 because I have 1, 2, 3, 4, 5, 6. When I rolled 2 dice, I had 6 squared or 36. When you roll 3 dice, you get 6 cubed or 216. When you roll 4 dice, it's 6 to the 4th because I have 6 possible outcomes to the 4 dices, which is 1,296 in size. All right, so the multiplication principle says that if I can do one task in A ways and a second task in B number of ways, then I can multiply those two to figure out how many possible ways I can number choices or sample size. Okay, there are 2 vocabulary words that we need to talk about before we move on. Sampling with replacement, okay? This would be like if I drew a number out of a hat and then put it back in and then I drew another number. Sampling without replacement means that once I draw the number, I don't put it back in the hat. Okay, so let's say for example that this right here, your code on your phone has 10 digits, 0 through 9, and you must pick 4 in order to create a password. So there are 10,000 possible passwords. Now, if you did not pick a repeating number, let's say once I chose 0, I was not allowed to choose it again, I would only have 5,040 possible passwords that I could make. All right, so let's take a look here at this yogurt stand. I have 2 flavors. I have 1, 2, 3, 4, 5 fruits and 3 nuts that I can do. If I must choose one from each, all I do is multiply 2 times 5 times 3. So there's a possible of 30 different yogurt parfaits that I can make at this particular parfait shop. All right, taking a look here, password, you must have 4 digits followed by 2 letters. The letters A and Z are not used. So instead of 26 letters, I now only have 24 letters because I can't use A and Z. So how many unique passwords can there be? So I have 4 digits, 0 through 9, 10 times 10 times 10 times 10, and 24 times 24 gives me 5,760,000 passwords that I can make by 4 digits and 2 letters. Just by throwing in 2 letters, I've made my password much more secure than if I had just used 4 numbers. So it depends on what you're looking at to protect, but I would definitely throw in some letters and not just the numbers. All All right, well, that's it for pop probability. I'll see you guys later.